Today I am addressing GME 18 batch G2 batch, and as I have finished steam turbine and I have given lot of notes plus question answers assignments. Also I have printed booklet for you all, so in the leave you can go through them, as we have now locked down completely. The whole Tamil Nadu is locked down. So I think to view this as a better opportunity or a blessing in disguise, so that you can concentrate on your studies and not to worry about too much about anything. Normally, usually we worry about money, health, relationship and prestige. All these four also is concerned with career also. In the career also, all these four is going, but everything is going to one day vanish. So no point in worrying. We have been worrying for last so many years. So there is no point in worrying. By worrying only we will increase the toxic level in the body, and there won't be any constructive achievement. So instead of worrying, let us be constructive. Let us utilize this excellent time for our improvement and learning. I have given in the websites also, learning all these things also. There are websites I have given. So go through those websites. You can join them also. And then I am forwarding this YouTube arrangement to the office so that they can send it to you. And as soon as you come back from leave to the college, you can go for the unit test, which I have already told you long time back. Just before the college is going to close down, I have already told you. So only we saw the steam turbine about how, though it is very fuel thirsty, but still it is used in cruise vessels and battleships and power generation. And we saw about impulse turbine, reaction turbine. We saw the compounding, pressure compounding, velocity compounding, pressure velocity compounding, and those components we saw: casing, rotor, diaphragm, nozzle, all these things we saw independently, and we discussed in the class thoroughly. Now coming to the point of materials for these components, we will discuss today, and with that this chapter is closed and you will be prepared for exam. Actually, anything you want to start, we have to see the factors that decide the material for steam turbine components. That is always creep is the main thing for steam turbine. Creep strength, which is the very deciding factor for the steam turbine components. First, let us see what is creep and what are its mechanisms. Before that, let us find out why do tungsten filament bulb fuse. That we have to see. Fuse means nothing but fusion. And fusion is melting, but filament does not melt because filament is made of tungsten. Whose melting point is almost 3410 degrees centigrade. So actually that kind of temperature we don't reach, the filament breaks. Actually, I want to talk about a little bit about creep and a little bit about fracture, because these are the two, fatigue fracture. These are the two things which is almost deciding factors for many of the components which are being manufactured. And to understand the mechanism, we are going to see the first one is this one. Second one is why the glaciers move. You all know what is glacier. Glacier means it is huge mass of ice floating. It is floating. Glacier. It's like a river, ice river. Huge mass of ice moving is called a glacier. Is it normal movement or a sliding movement? What is that? We don't know. So we have to find out that one also. Lastly, what limits the life of engine turbine blades? So what is the limit? What limits the life of engine turbine blades? All these three questions are unrelated but are related in one term called the creep. So all these three are related to creep. The filament is broken by creep mechanism. The ice movement is not normal sliding of ice, but breaking of ice by creep mechanism. And lastly, broken blades of turbine are due to creep mechanism. So all these three happens because of creep only. All these three happen. So what is creep? Creep is a time-dependent, continued plastic deformation at constant load or stress. The load being same, but the load or the stress is being same. There is a plastic deformation taking place that is called time-dependent. It is totally time-dependent. So this is called creep. The results of creep test is usually plot between time and strain, like the way we plot stress and strain curve. In creep curve, the strain plot as a function of time and keeping stress as constant. Whereas at various strain curve is known. So what is the phenomenon which differs in both cases? Creep is a high temperature phenomenon. Here high is melting point with respect to room temperature. So the creep is depending upon the melting point of the material which we choose for manufacturing. So actually a demonstration can be shown with two springs. One is made of lead and tin, other one is made of aluminum, and you just hang it. You can see for some time, every 5 minutes you can see the aluminum spring would not have deformed at all. No stress, extra stress, of course its own weight, but it would not have deformed. Whereas lead and aluminum will start elongating by itself without applying any external force or external stress. This shows that creep is a ratio of that is Tm, that is ratio of room temperature to melting point. If that melting point, room temperature to melting point should be less than 0.4. If it is less than 0.4, then the material will stay for a long time. Durability will be there, reliability will be there, dependability will be there. The ratio of room temperature to melting point of that particular material in use will be the criterion for creep. Creep occurs in 3 stages: primary stage, secondary stage, or steady state. Our third one is tertiary stage, where permanent deformation occurs. Similar phenomenon that occurs in material called fatigue, a characteristic behavior which is different from that under steady loads, because fatigue is also a phenomenon which leads to fracture. Fracture takes place under repeated or fluctuating stress, whose maximum value is less than the tensile strength of the material. This is very important. The fracture takes place under repeated or fluctuating stress, whose maximum value is less than the tensile strength of the material. So, fatigue fracture is a progressive beginning as minute or nascent stage that grow under the action of fluctuating stress. So, we saw the difference between creep and fatigue. More about this we will see in the Unit 13, properties of material. Second factor which is concerning about steam turbine is erosion resistance, because we deal with high pressure steam. The third one is working temperature, because steam not only has pressure but also has temperature. So all these three above factors are the main governing for material choice. We will see alloying elements which will increase the above factors. So in order to increase the strength of the above these three, we add alloy elements. Nickel increases strength and erosion resistance. Chromium increases resistance to corrosion and erosion. Molybdenum increases strength at high temperature. Vanadium increases strength and fatigue resistance. I have sent a paper also in that from 1994 to 2020 how the material improvement has taken place. Now latest all these VASP alloy and mnemonic alloys are come into picture, that their parts are all being produced in this. I have sent those papers to you. You can go through them. Normally the components, what are the components? HP casing, 3% molybdenum steel or 0.5% molybdenum or 0.3% vanadium steel. Rotors, if it is a solid or hollow or built up or cast or forged, chrome molybdenum steel or 0.55% molybdenum steel. Blading, 0.12% carbon, 12% chrome, or 1% nickel stainless steel, or 0.2% carbon, 12% chrome stainless steel, or 0.25% carbon, 12% chrome, 36% nickel steel. Nozzles always stainless steel or 67% nickel, 28% copper monometal. Blanks nickel or leaded nickel, bronze, 65% copper. Turbine wheel as of same like rotor materials. Diaphragm centers, mild steel. Rotors should be normalized at about 900 degrees centigrade and annealed at 660 centigrade for about 48 hours. All casing should be annealed. So this is the elaborate one. So I have sent the WhatsApp group. I have sent everything, especially detailed about the property, material requirements of these components. Please go through them and be ready for the exams when you come back to the college. Good day. Bye.